For centuries, educators operated on a single assumption. Our minds are a tabula rasa, a blank slate, entering the world with zero mathematical ability. Because we treat the brain as an empty vessel, mathematics must be artificially etched into it through sheer repetition and force. When we attempt to overwrite the brain's internal logic with rigid external rules, the friction often manifests as math anxiety. This mechanical approach to learning frequently forces students to adopt the identity of a non-math person before they've even reached high school. But if we look at the biological reality of the human brain, we have to ask a different question. What if the slate was never empty to begin with? This friction actually arises from a fundamental mismatch between how we are taught and the pre-existing software already running in our heads. Biologists call this underlying software numerosity. It is an innate biological ability to perceive and calculate quantity, completely independent of culture or human language. We see this clearly in the animal kingdom. When primates forage, they don't just guess. They consistently calculate and select the mathematically larger groupings of food. This calculation scans entirely different evolutionary branches. Corvids, like crows, have been observed tracking the exact number of predators entering and leaving a blind spot. Researchers tightly control these studies to ensure the animals aren't just reacting to visual cues, like surface area, or performing trained tricks for a reward. They are actively processing discrete quantities. To see if humans share this raw biological hardware, developmental psychologists turn to subjects who have zero cultural conditioning and zero language, infants. This chart tracks infant attention spans during a puppet show experiment. Researchers place one object behind a screen, add a second object, and then remove the screen to reveal only one object. When infants see this visually impossible arithmetic, you see a spike in their stare time. That extended stare time is cognitive surprise. The data proves that even before knowing a single word, babies have a hardwired expectation of mathematical rules. Long before we can speak, our brains are already actively calculating the physics and quantities of our environment. Behavioral psychology tells us this ability exists. Physical neuroanatomy shows us exactly where it lives. Deep within the parietal lobe sits a structure called the intraparietal sulcus. When processing abstract quantities, this specific neural real estate lights up. Crucially, while active, language centers like Broca's and Wernicke's areas remain completely dormant. We know these systems are strictly separated because of severe medical anomalies. There are documented case studies of patients with extreme aphasia who have lost all ability to speak or comprehend language, yet can still perform calculus. The biological evidence clearly reveals that mathematics is a dedicated physical biological system, distinct from cultural language or general intelligence. This brings us to an obvious contradiction. If we are born with dedicated biological hardware for math, why is high school algebra so agonizing for so many people? The answer is a translation problem. A profound neurological distance exists between our biological number sense and culturally invented Arabic numerals. Doing written math forces our ancient intraparietal sulcus to communicate with newly evolved visual and language centers, creating a difficult cognitive bottleneck. This explains conditions like dyscalculia or math blindness. It stems from a structural glitch in this specific translation pathway, regardless of a person's general cognitive ability. Which brings us back to the original assumption that we start with nothing. The blankness of the slate was an illusion, caused by a lack of the right instruments to see what was actually there. The struggle with complex math isn't proof of an empty mind. It's the sound of a biological system trying to learn a secondary language. We are all born with a mathematical blueprint. We are simply learning to consciously translate the brilliant calculations our brains are already doing subconsciously.